All right, so it's day 40 of 100 Days of ML, and what I'm going to be doing today is finding resources for learning CUDA. What I'm going to do is find a book and also search for alternative resources and add them to the README documentation. That way I have a reference to how to basically learn CUDA. And I think I already noted down this book, so I have to check out what the contents are of this book and see if it's worth reading or check for alternatives. So today is mostly going to be preparation for learning CUDA. I would give a small description of CUDA, but to be honest, I have no idea what it is. I just know that it's a software tool provided by NVIDIA for optimizing GPUs for ML usage. I'm not sure how it works or like what it even stands for. But hopefully at the end of however long this takes, I'll be very comfortable with CUDA and also comfortable writing programs in Python with CUDA. So first things first, I'm just gonna like scrape the web and see like what's popping with CUDA. Maybe search for like learning CUDA roadmap or something. Check out the NVIDIA developer guide. Check for articles. Learn using step-by-step instructions, video tutorials, and code samples. GPU accelerated computing with Python. Teaching resources. Access GPU. Parallel programming training materials. NVIDIA academic programs. Okay. Wonder if this is like free. NVIDIA's CUDA Python provides a driver and runtime API for existing toolkits and libraries to simplify GPU-based accelerated processing. Python is one of the most popular languages, blah, blah, blah. Interpreted language, too slow for high-speed computing. Compile, so Python compiler from Anaconda that can compile Python code. Numba. Python compiler from Anaconda. Okay. To run CUDA in Python, you'll need a CUDA toolkit and a keepable GPU. So there you're talking about cloud services that I can use if I don't have a GPU, but I have a GPU, so I'm chilling. First, download and install Anaconda Python and other packages and Conda. And then I want to check out if there's a Docker container for learning CUDA as well. That way, or some sort of Docker container that I can use for learning CUDA. So that way I don't have to set things up locally or globally in my environment. And I have to fiddle with that. So let's check this article over here. So I think this is the book that I was looking at earlier. It's also this book. So I think this is good. I mean, usually O'Reilly books are like pretty solid. Let's check out the table of contents. Learn CUDA programming. There is preface, introduction, high speed, high performance computing, technical requirements, hello world, vector addition, error reporting data type. So this is a lot about I guess it goes very in depth into CS, where especially microprocessor computer architecture and also operating systems, I believe. Global memory, device memory, shared memory, data cache, unified memory, thread programming. So yeah, memory management, thread programming, all these topics with threads and system memory is all just from um, microprocessor computer architecture and also operating systems, which I'm currently taking as a course in my university. So it might be a parallel way to kind of boost my learning of these topics, except this goes more into detail with the GPUs and accelerating the hardware that way. So CUDA thread programming, there's a lot of topics there. From the looks of it, I feel like this is going to be very hard to read, mostly because all of this is going to be new content. So I'm going to have a pretty hard time reading this. Kernel execution, optimization strategies, application profiling and debugging, scalable multi-GPU programming, parallel programming patterns. This is like very, very low level um, programming, very low level. So I need to see what the usage is for CUDA, try to figure out like how it's beneficial to learning CUDA. Kernel is a function callable from the host executed on a CUDA device simultaneously by many threads in parallel. Right, kernel operating systems. Yeah, sure. Execution configuration means defining the number of parallel threads in a group, number of groups to use when running kernel for a CUDA device. API basics, programming model. Okay, so I think CUDA, like in terms of data science as a whole, CUDA is more focused on the CS aspect of the machine learning system. It's not really the model building process, but hypertuning and optimizing the hardware that we use to train the models, which is pretty important because without fast hardware, you really can't get a whole lot out of the ML models. So let's see. Is CUDA worth learning? I want to check this out. Nothing much to learn in CUDA programming. C++. Few main sets of rules and semantics, and VCC compiler understands before writing a simple program for GPU, how to write a kernel, how to allocate memory in GPU, and how to launch it in the GPU. Everything comes down to parallel programming algorithms. That's the major challenge. So major challenge is parallelizing the code in multiple threads. Good parallel implementations of various data structures and algorithms. CUDA is just a language to write parallel programs. What you're getting yourself into is the field of designing parallel algorithms. Interesting. If you're into parallel programming and have a research interest in that field, CUDA will be a tool, will help you, no doubt. Okay, I mean, is it gonna help me with learning the full stack? Maybe not, but is it something that's nice to know? I think definitely yes. I'll be back in a sec. Right, I'm back. I had to go do something real quick. Okay, so for the most part, I think learning CUDA is going to help me understand how the hardware works. So it's going to give me options to basically, for example, if I want to work at maybe a company like NVIDIA or AMD to optimize their GPUs for stuff like machine learning, even Apple, I guess, or Google with their TPUs, it's going to give me a good option to go down that route. In case I don't want to work on the high level architecture with the pipeline, because the pipelines right now seems very new. Like TFX came out 2019. That's like only 3 years ago. And you don't see a lot of companies running machine learning models for their services at the moment. But since it is so fresh, it gives me the opportunity to develop something new with that technology if something comes to my mind. And I think it's the right time to really step on ML and use. I think the only limitation at the moment is figuring out ways to put it into production with the knowledge of the GPU or the hardware limitations. And learning the hardware limitations is really going to give me a better understanding of the whole problem at hand. So I guess that's in short why I want to learn CUDA, my motivation to learn CUDA, which I just figured out. Let's see. How many pages is this book? Looks like it has a lot of chapters. Beginner's Guide. Does it ever say how many pages there are? Or how many chapters? Is there a preview? Other books like CUDA programming by GPUs, CUDA by example. They have pretty low reviews. Oh, this one does too. Practical Guide for Engineers and Scientists. Let's check out the blogs. Number tutorial, 7 things you might not know about Numba. Well, these are about Numba. This is about the book. CUDA C++. Does this use CUDA C++? It might. I mean, I know C. I don't really know C++, but I know Java as well, so it's Java and C++ are very similar, and C is also, in terms of syntax, very similar to C++. So I feel like it shouldn't be too hard to learn, but if there is a Python version, I'd rather stick with Python and write code with Python. I mean, if I can learn the concepts with Python, I can always just learn the C++ programming language and transfer over the concepts to C++ as well. For the most part, the theory should be the same. It's just the way the programming language is written should be different. So all of this is written in C++. We go from here. Let's check out these blogs. Third-party library number. Let's check out a Docker container as well. So I'm going to highlight this book. I'm going to keep it. Probably going to purchase it soon. And I guess what's this for? Code repository. Learning. This book covers the following exciting features. Launch GPU, very effective. Instructions. So the software and hardware list. Getting to know the author. I mean, it would be so nice if they just included like a prepackaged Docker container for this. I might even like add it or suggest or contribute to a pull request and adding a Docker container for this with all the packages installed. So what exactly does this contain? A Python file with code. So that's nice. In case I need to refer to code repository, I have this starred. I'll close this now. What was I looking for? So I have a book set up. It's gonna be this. I gotta get the book. What else? What about resources on YouTube? CUDA. Introduction to CUDA. Siraj. There's one by NVIDIA. Are there any like series? That's CUDA enabled cards. Yeah, I don't really think there's anything to do with TensorFlow and CUDA. It's just the fact that TensorFlow uses CUDA. I guess this is another benefit if I do want to work for TensorFlow or work on developing TensorFlow code on a very low level, which probably is not going to happen, let's be honest. I think most of the low level code for TensorFlow is already set in stone. But it does give me that option to understand TensorFlow from the low-level perspective. Let's see. Starting using. Okay, Docker container for CUDA programming Python. Docker-based Python development. What's this for? With CUDA support. Let's check this out. On PyCharm or Visual Studio. Docker file. Requirements.txt. Blah, blah. Docker is reachable. What is this? So it's using Anaconda, running the latest Linux, runs a bunch of commands. So it installs using Conda, but on the Docker container. I mean, in the Docker container, so that's pretty neat. Sets up the directory. .py. Docker beginner's guide. Interesting. So I found some sort of tutorial. It's an hour long. Perfect tutorial to get started with Docker. Wait, is this for Docker? I don't need to know Docker. I already know Docker. So it's using CUDA 10.2, which is kind of old now. I think NVIDIA is using 11 point something, 11.1 or something. So I have to get it updated based on that. Conda version. Let's see. Docker images, Debian. This is an additional installation for mini Conda. Okay, so from NVIDIA slash CUDA, I need to change this. I'm going to check out NVIDIA Docker Hub and see what they're rocking. So they do have a 11.3 support for Ubuntu 20.04. Might something that I'll be using as the base file for my Docker file. I need to check if this is for Python as well. Like it should be for Python, I believe. It just installs CUDA version 11.3 and not even CUDNN. What's NGC? It's a lot of containers. Python. I have no idea what these are. Using TensorFlow 1.15, which is pretty old actually. Let's just check out the home page again. Building AI on AWS, speech recognition. Huh. Getting lost. Something like this would work. I just have to double check with the versions on TensorFlow. Not TensorFlow, CUDA. NVIDIA CUDA Docker Hub. So if I just update the version that they used in, I think I lost the article, but the whoever this guy is, I should be able to get the latest CUDA version installed on my computer. Okay, so I got the Docker container. I have to set that up. I'm gonna get the book, start learning on the concepts, and then once I have the Docker container set up, I can also run code. Probably follow tutorials on YouTube as well. That guy looks very young. All right, so that's pretty much the setup, I believe. The only thing that I'm a little wary about is the fact the Docker container part. But over time, I think I'll be able to figure out what dependencies I need, especially after reading the introductory chapters of the what's the book even called? Hands-on GPU programming with Python and CUDA. So start reading GPU programming with CUDA. So pretty much I'll be taking notes on my iPad. And I think once after figuring out the introductory chapters or going through them, I'll be able to set up the Docker container for the development environment. So maybe I'll just put it down for 42, but if things just do change, I'll just shift things around. Set up development. For CUDA. And I'll be using CUDA with Python, not C++. Okay, well, that was a short stream. I think that's pretty much it for today. It was mostly just a preparation for the upcoming days. And I did have to put the ML pipeline project on pause. What I'm going to do is try to contact people who have a high knowledge in NLP or TensorFlow and TFX and then try to figure out what the issue is with the transform component. But till then, I'm going to continue with my learning. So what I'm going to say is finished day 40.